My name is Dinorah. I'm Google Developer Expert on Android, and today we are going to be talking about something really cool. We are going to be talking about Lifecycle at scale with multi-platform. So, as you might imagine, first of all, a little disclaimer. This talk has many layers. So I'm going to try to go as smooth as possible, but please bear with me, because I promise you that I'm going to do some quick jumps from one thing to another, but I promise you that all these topics are related to something very specific. And that topic is obviously Compose. So this talk is about Compose, guys. With a twist. I have another disclaimer, sorry. So the twist is actually that we are going to do Compose multi-platform today. So this talk is about that. I'm sorry if you feel that it was about doing life cycles with your own code, your code in Swift UI or your code in web or anything that is doing on React. No, it's not like that. I'm sorry. So it's going to be about Compose multi-platform, but you are going to enjoy it. I promise you. So. First, let us start with a little bit of context. I think this is very necessary for everyone that is not on Twitter anymore or anything like that and doesn't know what is going on with updates on libraries, and it's really fine. So the first thing, does anyone saw this tweet? No? It's fine if not. Oh yes, you can see the tweet. This is the official announcement of the stable version of Lifecycle 2.8.0. This is one of the most incredible releases I have seen in a while, because this includes something really cool. Includes version of Lifecycle and view model that is now in Kotlin and can be used, obviously, for multi-platform compatibility, and this opens the door for everything. So, if someone is using already this library, you're probably really updated in your dependencies. If not, it's really fine. It just came out of the oven, has been on alpha for a couple of months already, so we are going to be talking about this. However, we are going to be focusing in life cycles and not the view model part. I'm sorry for that one. But if you want to use view models for multi-platform, if you have a project already in Kotlin multi-platform, you can start using view models in that part too. You just have to import the library as always, and you are ready to kick in. And you can consume it from Swift UI and other parts. So first, let's do it a quick stop with Compose multi-platform. Does someone has a project in Compose multi-platform? Like a gameplay, eh? It's production. But it is a production app, like a product, like, no? It's just to play around? Yeah, it's fine. Well, for all of the others that doesn't have any project in Compose, we are going to do a quick walkthrough. Because Compose multi-platform looks like something very similar to what Android Compose looks like. Yeah, we have a composable function with a little annotation, and you can put all your tree inside it. However, the thing about Compose multi-platform is that we are trying to achieve doing UI for Android, web, desktop, and iOS. So that's interesting. We have seen it before. It's very interesting. I think it gives us the chance to explore ahead and understand what is going to happen. Maybe for a little project, I mean, I work for a startup, guys, so this could save my life so many times. So, as Kotlin multi-platform, Compose multi-platform is not a hard commitment. You can start playing around, understand what is going on. If you remember, you can create a library, and this library can be used on a full Swift talk, a Swift application or a web application, because at the end of the day, multi-platform, what it generates is a library. So it's something very similar. You can go, play around, and understand what is going on inside of it. You don't have to do the hard commitment to move all your code base to compose multi-platform. It's not required. You can play around, you can understand what is going on, and understand if this is something applicable for you, right? It depends at the end of the day of what you want to do, what you want to explore. Maybe you want to have a little website, or maybe doing a little project for something that is very simple and very straightforward. And you can start using Compose Multiplatform for that part. So what it means for every platform, I think that's very important to understand and very important to address. So for web, they are mostly using something of Kotlin WebAssembly. It's WebAssembly at the end of the day. There is a trade-off here because WebAssembly needs to have, at least for the Kotlin part, it needs to have some type of garbage collection, right? So this part is actually not supported in all the browsers. So if you have a browser that is not using Chromium at the base, it's probably not going to work. Yeah. So Safari doesn't work. But most of the new browser and the regular browsers use Chromium, so you are going to be fine. And the other part is that iOS use, obviously, Kotlin native, right? Because what we want to have is a very easy way to go to Swift framework and Objective-C framework and try to consume the things that we are pushing to Kotlin multiplatform or Compose multiplatform, right? So we want to be able to do that easily. And for desktop, I don't know if someone is doing a desktop app, but I have to say it, is GVM, and very much like the things that are happening on Android, right? So for all of these, there are some trade-offs, obviously, because not everything in Compose multiplatform is stable. The only part that is stable is mostly what is going on in the Kotlin GVM, right? So that part is going to be Android and, surprisingly, the desktop. So for web, it's on alpha for obviously reasons. We need to work on that Safari support and doing the WebAssembly support for Safari. There is a little project that is already running. I can share it with you if you want to. But it's still on alpha. So if you go to the website of Compose Multiplatform, you're going to find that it's still on alpha. And for iOS, it's on beta. So some trade-offs, guys, some trade-offs. Who doesn't want to have fun doing an alpha and beta analysis, right? So the second part is that everything in Compose has a life cycle. Well, kind of a life cycle. It is a life cycle, to be honest. I want to start with an example. In Compose, the composition and the recomposition are very critical, right? Every time the user interacts with the mobile application, you have to do a recomposition of what the user is seeing. So because we have to do a recomposition, the flows of the data works very differently. So if the user clicks a letter A, this triggers a composition the first time, right? And the second time, when the user inserts another letter, is going to introduce a recomposition to the process, right? This is really important because recomposition is optimistic. It doesn't happen all the time and shouldn't be happening all the time. It happens only when something that has been affected change, right? If you are doing it correctly, right? So the thing about life cycle is that in Compose, there is a, oh, is that okay? Yeah? Okay, I got scared. For Compose, sorry for that. In Compose, obviously, how it works compose, how it works is that it has a tree of components, right? Everything is a tree in components. So every function, okay, every composable that you have is attached to a functional tree. And this functional tree, at the end of the day, sends parameters over the composable tree. So you start with some specific view that has another view, and you have to send data to these two functions. You usually do it over parameters, right? For the life cycle, this is a little bit different because there is a common life cycle provided for all the composables, and they are interconnected in all the entity of the tree, right? So this life cycle, at the end of the day, is fully shareable between these functions. And this happens because Kotlin Multiplatform, because Compose, sorry for that, Compose use something called compositional local. You probably have seen it or use it. If you are using material design, you probably know how this is working right now. If not, don't worry about it. We're gonna try to explain it today. So the thing is that compositional local, what it does is that create reference for the consumer so we can consume that values from a static position, right? So we don't end up sending multiple variables over the tree that doesn't change or change just a little bit. For example, your fonts, your colors, and obviously your life cycle. Because you don't want them to change all the time. You are focusing only on the changes that are required. And you want to have some recomposition if these change. Not all the time, only when these change. So compositional and local hold this data and pretty much give you a chance to access to them in all the tree that is hosted in that composition, right? So the first part is that obviously you have, we're gonna go over this code, sorry guys. We're gonna go over this code because there is some important things that are happening here. The first part is that obviously you have a default value holder that is the only thing is that providing a default value. So it doesn't do much. The provided also doesn't do too much, but actually what it does is that it triggers the recomposition composables when it's read for. So if you read the provided value, you're just gonna get what is going on in that state. But the important one is this little guy. So this little guy, you're gonna see it over all the compose code. If you enter what is happening when you use compositional local, you're always gonna see a referral to current. Current provides the value, the closest value that is located on the compositional local, sorry. So if you are trying to address or locate some type of colors, and these are available, it's gonna be searching the closest one of the current composition. If you are having two sets of colors, and you go from one tree to another tree, it's always gonna search for the closest one that is available. So if you have multiple composition locals of these colors, and you want some of them, if you want a tree to have some specifics, colors versus another one, the compositional local is always gonna search for the current version and the current value that is closest to one of these two trees, right? And this is really important because this gives you the chance to have compositional locals inside your compose functions. If you have compositional locals inside your compose function, this code can be some specific styles, some specific behavioral that you want to address. And all this other part that is on your function will not have it, and that's fine, because it's not gonna be in that tree that has access to that compositional local. So that's really, really cool. So have you ever seen the code in material design? No? Is someone using material design? Like the compose material design? Yeah? I do, I like it. It abstracts everything for you. But, well, if you go to material team, you are going to find something called composition local provider. You're going to find a lot of stuff in that composable function, but something that you're going to find is that there is a callback to composition local provider that is sending some values, and then it's created a lambda, right? And what is happening here is that to provide a new value to a compositional local, we use composition local provider. And it provides a function that associates everything to that tree specifically. So when you are using material team, you are going to find that material team has a lambda. And inside this lambda is going to be all these styles that you are seeing in this code. So you are going to see the color code scheme and the color indication and the ripple team. All of these are going to be accessible in that lambda inside of it. So every time you put a text field, a scaffold, I don't know, a constraint layout, a button, all of them, they are going to use the local color scheme values that are available in Remember Color Scheme. And they are going to use all the shapes that are provided over shapes. So everything is going to look and make sense over your mobile application, right? Especially because everything is a pair of keys and values. So this one is the key, and this one are the values. So the local ripple team is going to be the value that you are going to be able to access over all the composable trees, and the values are going to be material ripple team. If you have a custom design system, you're probably already doing something like this. So you can add your custom variables to composition local. Sometimes it's necessary. It's not for objects, but it's sometimes for things that you might need. Something like the colors, the fonts, the schemes, maybe some paddings, some specific things that might be repeatable over all your mobile application, right? So this part, you can use something that, like the code that we were seeing, that is using material design. But inside that function, inside composable composition local provider, there is something going on, right? This function receives a set of values. It can be anything. It has to be a key, a value. Remember that. And it can add a content. And this content is usually a lambda. So what is happening here? What is happening here is that it's trying to find the current composer, so the closest composer in the hierarchy of the tree. I'm going to start trying to provide all the values that are available for that tree that you sent for this compositional local. And then it's going to grab the content, so everything that is going to be on that lambda function in that content composable function is going to have these providers and these values, and once it's on, it's no longer going to use it. So if you are grabbing everything inside material team in your mobile application, that's why all the buttons looks like the colors that you are putting, looks like with the typography you are putting, and everything is just binded over that content lambda. This is really important, right? This is probably is one of the most important things of how composition local provider is working, right? So the other thing is that you need to do you might need to understand how it works to provide on composition local, because this can be used to provide values on the composition local provider, right? Associates a composition local key to a value that is called to the composition local provider. Associates, at the end of the day, the last part, the provider's default, associates a composition local key to a value in all the composition local provider. If the key doesn't have an associated value. So this pretty much makes sure that all the values in the tree has a key and has a value that you can access statically over the composition and the composition tree. So let's see a clear example. And this example is going to be obviously with a team of Compose. So if usually you have something like this. I'm not saying this is exactly how Compose is working or how Compose is working on the Iterachi. This is just a demonstration. But you usually have a root, and this root has some theme. You can make your own theme. You don't have to use material design. So if you want to create your own theme, it's really easy. I'm going to give you some tips at the end of this talk. Then you can grab your composition local provider, create something for you, and store all the values that are available there. And by the end of the, in all the other components that are going to be consuming that theme are going to have the same styles that you decide to put in the composition local provider. This is a very small example of how you can create your own design theme using material theme. So what is happening here is that we are creating a composable function that is going to be a design theme where we are passing some colors that we are going to use, and we are calling composition local provider, right? And composition local provider is providing all the colors that are going to be used in the application. Then I'm wrapping material theme, so everything that is happening in that theme is already using that functionality. So with this, you can create your own custom design system. If you don't have one and you want to try it, you can do it in this way. But we use composition local for creating themes, colors, and other variables that are mostly not changing. And we kind of do it on Lifecycle. But before we stop that, I just want to recommend there a talk. If you want to create your own custom design system using your own material design and creating your own variables, you can go and watch this talk about custom design system in Compose by Ryan Harder. If you want to extend material design, I'm going to promote my own talk that is about Compose and material design. But for Lifecycle, it's a little different. Because for Lifecycle, if you want to access the Compose, inside a composable function, you want to access the Lifecycle, you need to call the compositional variable that is available. That is local lifecycle owner.current, right? Except that is very different of what we were looking. And the reason why it's different is because, is the gray color. Sorry, maybe I delayed that slide. So when you go to local lifecycle owner.current, you're going to find that local lifecycle owner is actually a static composition local of. That is a variable that is mostly static. So it's going to, every time it changes, it's going to trigger the full recomposition of the Iterachi that is attached to that part. So it's going to trigger all the three. The compositional local is only triggering some part of it, which is very different, right? It's only scoped to the most closest child of that Iterachi. So mostly, lifecycle owner is hosted over compositional local, which is really cool, because now all the trees in that composition is going to have the same life cycle or something very similar, and they can access to that life cycle over the compose tree, right? So if you remember, sorry for that. Let me go back. The part of the local lifecycle owner is calling current, right? If you remember, current is something that we already discussed. Current is that part of the compositional local that is going to try to search for the most current tree that is available for the composition, right? So when you are trying to do access to that life cycle, you're going to notice that this life cycle is going to try to address current. And the static composition local of reads a static value, in usually changing these values make all the content in all the Lambda to change for the recomposition. And the other part of this, is that Lifecycle needs to address Lifecycle Owner. Lifecycle Owner is an interface that it doesn't look like it does much, but actually is called in Lifecycle. Lifecycle is a full class that is in charge of all the events and the states that are changing over the tree, over the views, and all the fragments, and all the activities, and pretty much of the lifecycle of your mobile application. So with this, we are going to jump to another topic. And this topic is going to be lifecycle, because they are very complex, usually very complex. So the first part of lifecycle is that you usually have this type of mobile application, right? You have activities, fragments, maybe some composables, and you have some classes. Usually, all these elements can have some type of lifecycle. And you are going to say, yeah, but classes can have a lifecycle? Well, not exactly. Let me give you first a little bit of context. What it happens with lifecycle is that lifecycle depends on two things: lifecycle owner and another class that is called lifecycle. Inside this lifecycle class, you are going to find something called states and events. And inside lifecycle owner, you're going to find that is this interface is getting called on lifecycle event, on view tree lifecycle owner, and process lifecycle owner. All of these functions are usually called when you are starting an activity, starting a fragment, or doing something with like something that has a component that might need to use a lifecycle. So let's first start with the states. States are the stages on the graph, on the general graph of the life cycle. So the stages, you probably know already what are they, because the states are usually these operations: destroy it, initialize it, create it, resume it, and start it. What it does is that it creates, initialize, and destroy all the stages over the life cycle. You're probably using it, or maybe not, and this is totally fine, okay? But if you are using it, if you are using on resume, on pause, you are probably calling this type of states in some part of your code. Because there is another part that is the events. The events are the edges between these other states. So the events are the ones that I was telling you, on create, on start, on resume, et cetera, et cetera, et cetera. And they mostly create and destroy everything that is going on in the lifecycle. These are the operations that you usually use, like on pause, on destroy, or any. To give you a more classic visual representation, what happens is that you have the event and the function, right? So the event is the state where the life cycle is when this function is getting called. So for onCreate, once you call onCreate, you go to a created state. This happens on started too, and with onResume, and with onPause, and it happens with onStop and onDestroy. You always call the function, and then you get the state. These events can be used on regular classes. So you can create your very, very much custom lifecycle owner that understands how it's going the lifecycle without using it on your activities. So let's see an example. So I can have a really regular class that is going to be extending the full lifecycle observer. And inside lifecycle observer, there is some functions that I can do override. And these are on start, on resume, on pause, wherever you want. All of them are available in this interface. So if you start using this type of class, inside your mobile application, you can attach this to an activity or maybe another thing like your full application. If you want to understand how is the life cycle of the application and not just the fragments or only the activities and only some specific parts, you can use this type observer to do a deep dive on how the life cycle of your mobile application is going. The only thing that you need to do is that you need to attach this type of classes to something, right? So you can attach it to the application class using process lifecycle owner and add this observer. So this gives you the chance to have that, that information of the lifecycle in your general application. Lifecycle depends on many, many other things, so I'm gonna go very quick because today, inside the fragment, these life cycles are reported in some specific degree, in some specific areas. So every time the life cycle initializes, we are doing a registration on the life cycle registry. And every time we are setting a view, we are reporting that life cycle to that view. And we are doing back and forth with multiple steps in the life cycle of these fragments, right? So at the end of the day, what it does, lifecycle registry, is that it handles of the observers that we are having for the state and all the events that are happening in the lifecycle. And it can be used on fragments, on activities, on classes, and it mostly handles all the dispatch of all these events around the process of the activity and the fragments. So now that we are talking about these life cycles, there is another thing that we need to discuss, is that life cycles are mostly everywhere. And when I say everywhere, it's because I lied to you guys. This talk also includes a lot of things about iOS and web, because they have life cycle tools. And what is happening in life cycle on iOS is very much similar to what is happening on Android, because in Android you have a life cycle for fragments and activities, and you have the life cycle of the whole application. In iOS, it's also something that happens that way. This is a life cycle of how the application is moving, and this, another one, is how the view controllers are getting handled in that life cycle. So it looks pretty similar to what we have on Android today, because we have this part that it says that the view will be appearing, that the view has appeared on the screen and the user can interact with them. So we have on resume, and we have obviously on stop. All these events, now with the rewriting of lifecycle and making lifecycle simpler over the process of rewriting this to compose multiplatform, has given us the chance to address mostly the most important events that are happening in the view controller and the iOS application, right? So you are going to be able to understand what are the edges and the changes on the graph on iOS using compose multiplatform, which is great, right? Because we have a view did disappear is part of the view controller that is going to be part of on stop event, right? And we can listen into that changes inside an iOS app using compose multiplatform. And we can address all the stages, such as on start, on pause, on resume, on stop, on start. This gives us a huge opportunity to understand and simplify the life cycle of the iOS mobile applications using what we already know, right? That is a life cycle of Android. On the other hand, we have web, which is a little bit different. Because web, what it does is that it has multiple stages, but not all of them. You don't have on start, because always the page is attached to the browser. And you don't have on destroy, because on destroy happens when the user clicks and closes the browser. But you have other things that are available. For example, blur or focus, that is going to be a part on the lifecycle events on pause and on resume. If you want to use compose multiplatform for web, unless you are going to be stuck with a Swing that is mostly Java, right? So For the Lifecycles events that are existing inside this Swing graphic interface, builder for graphic interface, you're going to have the chance to have on stop, on start, on resume, on pause, and on destroy. So that's the most critical lifecycle events that are happening inside a new version of Compose multi-platform. So the events that are going to be triggered, and I don't know if you're familiar with Swing, but are going to be the ones that are already available in the life cycle of a website that is using Swing. So this is going to be window inconfined, window day confined. All of these events are going to be the same that you are going to be able to have in Compose. So finally, at the end of the day, Compose gives us the chance to do something really cool. Now that we know that what is going on with the life cycle, the events and the stage, and how the composition is working, we know that, first of all, the composition requires a life cycle, right? And this life cycle can be used inside all the trees that are available in the iteracy of all the mobile application, right? So we have that. And we know how the events are working. So we know that the life cycle has some specific events, and these events are getting triggered in some specific areas. So with all of this, we know that with Compose multi-platform, we can generalize the lifecycle management of the Android, web, desktop, and iOS mobile the iOS applications, right? So now you can write your code of Compose multi-platform and do it once and understand how that life cycles are changing in an iOS application when the user is doing on pause, is going to foreground, he's getting a call, and you can simplify that process using Compose multi-platform. So now you can probably write a library that handles all the stage that you are having on your life cycle without doing it back and forth between Android, iOS, web, and desktop. So with this, Kotlin multi-platform and Compose multi-platform give you the chance to simplify the work that you are doing already. So my name is Dinorah. This was Lifecycles at Scale with multi-platform. So thank you so much.